So thank you, ladies and gentlemen. I welcome you all to this second segment of the Responsible Artificial Intelligence and Machine Learning Innovations in Information Management Practice. At this stage or in this segment, I would like to let us have a practical set of review of what artificial intelligence and machine learning engineers do, and for which we can better appreciate some of the earlier discussions that we have heard. In this project, we will be using our Python notebook, and Python notebook is actually available if you are a Gmail account holder. If you're a Gmail account holder, you can be rest assured that you are carrying with you huge resources that you may not even know that exist. You may not even know there are some programming and powerful tools that go with you on your Google account. And this tool here is called Google Colab. And the Google Colab will enable you to program as much as you can, leveraging even external GPUs and powerful GPUs to render medium tasks, medium to very high-end processing, and some external CPUs to render a whole lot of data. It does not matter sometimes how huge some of this could be. So in this particular project, I want to very quickly just run through a project that's involving natural language processing. And this time we'll be looking at airline customer review sentiment analysis. And this is one of my project works with Great Learning in collaboration with the University of Texas at Austin. Okay, we will see in this project that usually most problems that artificial intelligence is meant or is being developed to solve will always come with problem statements. So we will always want to know what is actually the business context. Now, in today's digital age, social media platforms like Twitter have become prominent channel for customers to share their experience and opinions in the airline industry, and the airline industry is no exception. Passengers frequently turn to Twitter to express their thoughts, feelings, and express experiences, related to their travel, air travels. The ease of access and immediacy of social media has empowered customers to voice their opinions in real time, making it a valuable source of feedback to airlines. The airline company recognized the immense value of these insights to understand whether sentiments and continuously enhance the travel experience. However, the airline company faces a significant challenge with the rise of negative feedback on social media. Negative sentiments expressed by customers become a crucial problem to solve, as they can lead to several detrimental effects, including one, customer churning, where most of their customers might be looking at their better competitors and switching over, therefore they'll be losing business, or reputation damage, where persistent negative sentiments, if left unmanaged, can tarnish an airline's reputation. And the other is, of course, financial losses, where loss of revenue can occur if negative sentiment drives passengers away. So we will actually try to see how we can help in this area by using artificial intelligence modeling concepts and techniques to see how we can help these airlines. The problem definition actually goes to speak about the airline that's having the issue, and that was as I've expressed at the beginning. Most of the time, to get started, we have our piece of data. Our data will always be factual, will be the real fact and representative of the problem. So in this particular case, we have tweets IDs, a unique identifier for each tweet, airline sentiment, which is the sentiment label for the tweets, such as positive, negative, or neutral. Airline sentiment confidence, the confidence level associated with the sentiment label, and of course, the negative reasons, a category indicating the reason for negative sentiment. Negative reason confidence, the confidence level associated with the negative reason. Airline, the airline associated with the tweets. Airline sentiment gold standard sentiment label. Name, the username of the tweet author. Every tweet must have an author and a handle. So retweets count the number of tweets that the number of times a tweet has been retweeted. Text, the actual text content of the tweet, coordinates of the tweet, then tweet created, the timestamp when the tweet was created, the tweet location, and of course, lastly, the tweet time zone. So this actually forms the social media set of data that are actually involved in the data sets to be used in the particular case of sentiment analysis. So the very first traditional thing to do when you are actually running Python programming and Python techniques on Google Colab is for you to initially try to see how you can build, how you can actually initialize all your libraries. There are a few Python libraries that you need to initialize. And here I've just started with the first row here and install some of the relevant libraries that may not have been available and all that. And the system has finished doing that at the moment. And the next I go to install this, which is actually another relevant library resource. And after that, the actual libraries where I need to import NumPy, I need to import the pandas and several other matplotlibs, the Seaborn, and several other Python libraries that are required. So I need to also ensure I activate the enable these libraries to be activated, which I've just done. The next is that I have some set of data. Perhaps I'll share this data. This data about these tweets and information from the customers will most of the time will be found either in a database, in a text file, the CSV file, for instance. And what we just need to do is to, of course, direct our notebook. What we mean in notebook here is the programming interface on Google Colab. And a typical instance such as where I am currently is called the Python notebook. And of course, from here, we need to be able to point to the location of the file. And I'm directly saying that my notebook should directly access my Google Drive location, which I need to mount. The very first traditional thing is for me to try and mount that drive. And Google obviously will want me to verify that I'm actually the owner of the account. And I need to do that by ensuring that I can access the account myself by authenticating access and the relevant identity and information. So once I'm able to do that, it will be able to connect my activity to my Google Drive so that it can actually get to continue with what I plan to do. So Google Colab there, trying to have me verified, which I think it must have done, and I can continue. And that is now trying to confirm that it could validate what I have just supplied so that it can give me access to my Google Drive. That is also a point of safety. Not just anybody can access your Google Drive and do this. You have to authenticate that you are the one doing what you're doing, and it will use the resource local to you. And my drive has been successfully mounted. The next is that the information about the notebook is actually in a CSV file, which is available in a file, is a CSV file, and the location is also accordingly is properly identified and defined. So because it has ticked it here within a second, goes to show that yes, the file was successfully identified and found, and from there, this point going forward, I can begin to interact with the content of that file. So the next is that I want to just create a little, creating a copy of the data set. Now that I've actually read my file and I've moved it into a data frame called the DF, I may want to see how I duplicate it so that I don't actually work with the original, so that I can protect my original source of data. So to doing that, I use the Python instruction that says df.copy, and this will give me a duplicate of it into another data frame called data. And that is what has just happened now. So after that, I begin to work with the data. So under data overview, which is the next segment of what I need to do, I need to begin to do some data checks, checking the first 5 rows of the data. Checking the first 5 rows of the data, I can just say that, I can achieve that by just saying data.head. Data.head will be able to just share with me the first 5 rows of a data set, the data frame data set that way. So as you can see, I can see my column 1, tweet IDs, second column, airline sentiment, the third column, airline sentiment confidence, negative reason confidence, airlines, the airline sentiment gold name and all that and the rest of them. And that continues till the last part of the data. And this set of data can grow into millions, thousands, and just depending on what your problem, the area of the problem you're solving is about, this data will be about what you're trying to solve anyway. And if this was about a particular airline or a particular maybe multiple airline services and all of that, that will be the set of data that obviously we'll be working with. But what we said data.head will just give us a snapshot of it, not just the entire thing. But other instructions can be offered if we need additional information, of course, with more Python instructions. For next one to perhaps just look at checking a customer review. One of these could just be to check a particular customer review on column 3, which could be like your column 4, because the indexing starts from 0, 1, 2, 3, and in this case would be like a 4th position on that column. If you look at here, being 0, 0, 1, 2, 3, and so on. So here we can see that we have information here that says that for this particular location, says that US Airways, fortunately, you have staff like Lynn, S, and Didi who actually understand customer service and simply being nice. So this might just be like a positive comment about some staff of the airline and all that. But then these were part of the tweets that were involved with that data. And we can continue. We may want to look at the data shape. What does the data shape means? If I do this, it just simply tells me how many rows are involved with the data I'm working with and how many columns are involved. So in this case, we have about 2,913 rows of data as well as 15 columns of data. So that is what the data.shape from your Python code says. It says data comprises of about 3K customer reviews. Okay, so of course this set of data is pointing to what we have, the real subject matter, which is about customer reviews about airlines. So there's something we call the missing value, because sometimes we have data, not every time like that data can be accurate, you know, in terms of completeness and all of that. So if we want to check null values, so you could just say data dot is null dot sum axis that, and of course this will share with you about some of the columns, like some of the columns that we have our data on actually have missing values across multiple columns. Like we have missing values on negative reason column, we have missing values on negative reason confidence, we have negative values on airline sentiments gold, we have negative reason gold also have some, tweet coordinates also have, and of course the last of tweets location and time zones also have some missing values. And we traditionally should be able to fix issues around missing values, and there are methodologies for fixing missing values and all of that. Checking statistical summary. If we say data.describe will be able to give you that all the bounds of our 2,000 or almost 3,000 rows of records. You'll be able to see the counts, the mean, the standard deviation, the minimum, the 25 percentile, 58, 75, and the maximum. And all this can be given across all the fields. And this also points to unique information such as tweet ID, which is a unique ID for a tweet, so we cannot discard it from our analysis. We see that there is a minimal retweeting of customer tweets. However, this might vary by customer sentiment. So we'll check about that. So we also move into the stage where we call the exploratory data analysis. Popularly, we just say EDA. In this area, exploring data is very, very important. When you have data, we have to explore the data. We have to look at what's particularly unique about them. And that is what this part does. And some functions here tries to create bar plots to make data meaningful, to at least begin to do some visualization, for which under the univariate analysis area, we will be able to look at each of those data points or a combination of the data points and begin to plot bar plots or other types of plots, plotting on them, like in this form of this thing, this set of data. We are actually interested, of course, in looking at the bar plots of the data and, of course, looking at the airline sentiment. And that could be by way of negative, how neutral, and of course, that way of being positive. And you can see that the negative comments, particularly on this particular data point, shows that you almost have about roughly 7.7% as negative comments and all of that. Majority of the tweets are negative as this, followed by neutral at 13% and then positive at 9%. That is, you can actually do this granular checks at data point level. Negative reasons, we want to also check that, where we also run this command here to plot based on the data to show us what that is all about. You'll realize that bad flights is low, can't tell is 8.4, canceled flights is almost 6.5%, and then customer service issues rise by about 27.8. Damaged luggage is low, and we have flight attendant complaints 4.2, booking complaints, we have late flight, we have lost luggage, long lines, and all of that are the things we get, and these are things we can really use to portray so much information. Then distribution of tweets, his plot can actually help in this direction, where a majority of the customer tweets are now are not retweeted, and this is shown by how this his Instagram plots are shown. Then from there we can move into the bivariate. The bivariate here is actually looking at one data point with another, and we are looking at how this actually would better show more concerns. Like, for instance, in this case, we looked at the bar plot and the retweeted issues with the airline, which is still centered around the airline sentiments, and we're able to see that splitting words, excluding words, including words starting with these are just the methodologies if you want to really filter and get the right words to be able to build very, very accurate word clouds, for the sentiment that you're trying to build. Word cloud for negative tweets, you need to determine that. This is actually where we can build a word cloud for negative tweets. We'll later talk more about what word cloud really means. And we can actually now run this to see how this gels with the word cloud for negative, for which if we can now, when that finishes, we can now run the next to show the real signs. Like this was already run. Okay, let me just also run this, and this will show us the up-to-date image of text that depicts negativity. And you can see it's about flights, it's about this, about that, and people need help, hold, hour, lane, plane now, and so many things, delayed. These are things pointing to some negatives. It says here, tweets with negative sentiment frequently contain words like cancelled, customer service, hold, and delayed. People might guess that customer tends to have a negative sentiment when their flights get delayed, cancelled, or the customer service is poor, which is what you expect in some instances. And at the same time, you also have word cloud for positive situations. And some of the tweets that we also got, particularly for this project context, will be pointing to things that were positive about the airline. And this is also possible that we can also get information based on what the data that we got also had. Sometimes the processing time here could be much because of size of data, and we will just try to see how we could just have a rundown for the purpose of just sharing this after our presentation. So in this case, you realize that fine, it's all about customer, it's all about flights, it's talking about great help, and back airways, tanks, and all that, helpful, service made, gates, and all that. So we realize here with that tweets with positive sentiment frequently contain words like thank, great, appreciate, and kudos. These words portray satisfaction, which is what we would expect from customer with positive sentiment, and others like crew, attendant, and all that. Just for the more descriptive words about the word cloud is that positive and negative word clouds. A positive word cloud highlights words associated with positive sentiment connotation or connotation. It is often used in sentiment analysis to visualize most common positive words in a data set, such as customer reviews, feedback, or social media posts. For instance, in a collection of positive customer reviews, a word cloud might, prominently feature words like excellent, happy, love, great, amazing, and satisfied. Negative word clouds, that is here in this case, a negative word cloud highlights words associated with negative sentiment or connotation. It helps visualize most common negative words in the data set, providing insights into areas of dissatisfaction or concern in a collection of negative customer review. Don't forget that the project is about trying to help the airline organization so that they don't lose customers, so that their bottom line doesn't go down, and so that can be on top of it. So this will be, they should be conscious of what social media is affecting their overall business. And of course, these are things they don't have to waste any time on. So later on in the process, you go to things involving data processing will be engaging. So there are things about having to do some data processing to do some further work, because we are going to adapt so many other models to begin to get certain results, so that by the time you are done by the end of the project, you should be able to confidently telling these organizations, this is what to do, these are things to recommend. And of course, once they follow some of those things, they will find the work of a data science engineer quite useful and relevant. And that is part of the real crack importance of artificial intelligence. And further below here is the real adoption of very familiar models. Some of this model loading and evaluation is key. In practice, like we have the Google Flanty 5 model, where this was developed by, the Google Research, and it's called, it's a fine-tuned language net, where FLAN with text-to-text transformative architecture. So the Flanty 5 excels in various NLP tasks, including translation, classification, and question answering, and it is known for its speed and efficiency. Some of us have used, and actually are enjoying some of this in so many applications, but this is actually the bedrock of what they do. And it's actually important for us to be familiar with some of these things. See, the artificial intelligence activities are actually sets of hobbies and sets of processes that man has to thoroughly understand and need to be a part of, for you to be a part of artificial intelligence. It's not about a phobia. We can't stay afar and understand artificial intelligence, especially how it impacts who you are as a doctor, who you are as a psychologist, as a pharmacist, as an accountant, and so on and so forth. You have to be part of the process, and for you to be able to adapt it to suit your particular case. So we could actually do more in subjecting a lot of other token models to be able to get and achieve a lot of things. And in here, some of these models are already made. So what people just do is that they do not rewrite them. They actually sometimes just use the existing ones, especially when they could. Some of them could be free. Some of them have licenses you need to pay for. But I think they are already made up. That, like for instance, in the generate function here, the following arguments were used. The max. Some of them will have parameters like the max length. We have parameters like the temperature. We have parameters like the do sample and the whole lot. And the meaning of this, all these are also available for if you pick up lessons in some of these areas, because they are actually very, very relevant and useful. Like for instance, we try to see how we can, after adopting all some of these models and tokens that I said they have been designed by some authors before now, they can be applied to a set of data, and you can see from the data, he was able to pinpoint US Airways certain messages and text from the tweets saying that this particular one says that the US Airways just hung up on me again. Another waste of an hour of my time. And how am I supposed to take a look, take a book? How am I supposed to book a one-way flight back? You know, it now reports like, you know, feels that the website was a bad one. So this is actually an actual sentiment that depicts a negativity. So that in the case of this, there are now what we call the system, the prompting. You know, you have to now begin to write some prompts that are able to look at the data and begin to consider certain roles or certain attributes and be able to come up with things to be able to tell the world what this set of data is. And of course, at the airlines, people are able to get real-time information, as it were. So this is a typical form, this is a typical prompt being generated, for instance. So you need to build this. It says categorize the sentiment of the customer review as positive, negative, or neutral. So, and it says a whole lot of other things. So it's going to follow this format and build a prompt called sysprompt. Now, much later on, you can now begin to see that by the time some of this prompt is now applied, it says that this has seen a negative because it was actually pointing to a particular set of data from the data set. So, but then the model was able to correctly identify the sentiments here, you know, so because we're actually pointing to a particular array, a particular spot, the location of a particular set of data. So it was able to read that text and is able to say whether it was positive, negative, or otherwise. So going forward, you now realize that there are several other sentiment predictions that is possible based on what we are doing. So just follow all the steps to ensure that we can actually, you know, reach out to this data and be able to build better meanings. And the most important, communicate so that we can save either the customer or the service provider at any point in time at the airport so that they can know what to do immediately. And because of the size of data, like I've mentioned, we need to be a bit patient and be able to wait for certain processes to complete because it has to actually use this algorithm to exhibit all the things that I needed to do so that the necessary and expected outcomes are given. So for the purpose of our talk today, I may just want to round up by just swiftly moving across the other part of it, that creating confusion matrix may be important because when that is done, it will be able to build confusion matrix that's able to state the relevant determinations of the previous part of the modeling and give us some set of accuracy. And this set of accuracy, we can now begin to look at it if it is actually ideal, but if it can be improved, we keep on reprocessing to improve. We need to do model testing by improving what we are injecting to get what more satisfactory results, creating confusion matrix and the rest of it. And I think a lot more of this because in itself is a major work to be done. In summary, we analyzed the distribution of negative reasons and identified customer satisfaction issues and late flights as the predominant factors and driving negative sentiments. So we processed the text data to analyze it and gain insights into what could have resulted in negative and positive customer experience through word clouds. We used the Google Flan T5 model to build a sentiment analyzer, and that achieved about 85%, 82% accuracy. The model, however, was unable to capture the nuances of neutral sentiments well enough to make accurate predictions in those cases. Once we improve the performance of the model, we can use the model to make informed decisions and enhance the service provided by the airline to offer a better customer service. I think at this juncture, I would actually say thank you to everyone who has been here with us, and I'm sure this is a body of knowledge, and I'm happy for the Institute of Information Management as we are here, and we can actually form that central crux to see how we can advance artificial intelligence and responsive artificial intelligence and machine learning upskill and skill education across the country. And in fact, Africa, as we have actually initiated the AI labs for the purpose. Thank you so very much, and thank you for listening.